Hello everyone, my name is Salsabila Farah Azzahra. You can call me Farah. In this video, I want to tell you about parallel lines cut by a transversal and angle relationships. So let's go check it. Enjoy!
Hey everyone, thanks for joining me on this lesson. We are going to start out Indiana's home state of New York, home of the Statue of Liberty, the world's best pizza. Seriously, the best in the home of the world's famous New Year's Eve ball drop at Times Square. Now we are going to go ahead and use Google Earth to take a closer look at the location of Times Square on the island of Manhattan. And now we can see from this map that the roads in New York City make a great network of interlocking streets and avenues. Notice that our streets run somewhat horizontally and that they are parallel to each other, and we should know that parallel lines never intersect. We should also notice that our avenues run somewhat vertical and they intersect our street in a way that makes them perpendicular or that they're from right angles. And looking at the map this way should help us to better understand why for the most part Manhattan utilizes a grid system. Now notice that Times Square is located along a street that traverses this grid system. Now you have probably heard of the street before. It's called Broadway, and Broadway is unique because it does not run parallel to any of the other streets on the grid. And when parallel lines are cut by transversal, like in the case of the street map, we have some very unique and characteristic angle relationship which we are going to go ahead and explore future in this lesson. So let's call an Uber and get out of the city. So now let's go ahead and extend our thinking. We can start out by looking at the parallels and we'll say that CF is parallel to JK. And these parallels are cut by transversal. Now just note that transversals can look a number of different ways. They can even be perpendicular. The point is the angle relationship will always be the same no matter how the transversal looks. But for the example, we will look at transversal that is not perpendicular to parallel lines. Now, when it's transversal cross through parallel lines, it creates a bunch of angles, and we want to go ahead and explore the relationship between these angles. Now, if we pinpoint of those two sets of angles, we should notice that they look pretty much identical. In fact, if we take our two power lines and overlap them on the top of each other, we can see that the angle measure of the either line are going to be identical, and this is very important property of parallel lines cut by a transversal. Now, what this relationship tells us is that when we have a parallel line cut by a transversal, we can say that the corresponding angles are congruent. So if our obtuse angle on line CF were 122 degrees, then our obtuse angle on line GK would also be 122 degrees again because corresponding angles are congruent. Now here comes the cool part. If you know one of the angles, you can find all of the remaining unknown angles. Let's start out with the angles directly opposite or vertical to the angle that we just found, which was 122 degrees. We know that vertical angles are always congruent, so in this case, the angle opposite are also 122 degrees. Okay, how do you find the other angles? Now we should remember that angle that are linear pairs are supplementary, meaning that they have a sum of 180 degrees. So if one of the angles of our linear pair is 120-22 degrees, I can find the other unknown angle by asking the question 120-22 plus what number would equal 180, which is the same as subtracting 120-22 from 180, whose difference 58. So now I know that the supplement to 120-22 degrees is 58 degrees, and again I know that all corresponding angles are congruent, and I also know that all vertical angles are congruent. So now I have enough information to fill the measure of all the angles on the diagram. So now let's go ahead and look at another example for parallel lines cut by a transversal. And we'll try to make some generalization about the relationship between the angles that are formed. So let's just say that we know that one of the blue angle has a measure of 30 degrees because we know that corresponding angles are congruent and the vertical angles are congruent. We know that all of the blue angles have a measure of 30 degrees. We also know that all of the orange angles have a measure of 150 degrees because they are linear pairs, meaning they are supplementary, so 180 minus 30 is equal to 150. And again, this should really drive home the fact that if you know one of those angles, you can find all of the angles. Now, since we are all about visual learning here at a Mess of Math, I want to share with you guys something that I call the X and O mindset. This is a helpful little technique for you to better understand the relationship between the angles in any situation involving parallels cut by a transversal. Now, this mindset involves differentiating between the obtuse angle and the acute angles using some kind of diagonal mark. So, in this case, I have a diagonal orange streak for the obtuse angle and a diagonal blue streak for the acute angle. Next, I'm going to label all of the acute angle with the letter X and all of the obtuse angle with the letter O. Now again, you can reverse this and make the acute angle O and the obtuse angle X. As long as you're consistent, this mindset method will still work. Now, with this visualization in mind, we can conclude that all the angles labeled with an X are congruent to each other, all the angles labeled with an O are congruent to each other, and any combination of an X and O angle will have a sum of 180. So any X combo represents a linear pair. So now let's go ahead and apply this EXO mindset to an example question involving some algebraic expression. So in this example, we want to find the value of x and find the angle measure of all the angles in the diagram. So in this case, we label our obtuse angle with x and our acute angle with o's, and remember those angle relationship. Now in this case, we can see that our two algebraic expressions are both O, so I know that I have to set them equal to each other since the two angles are congruent. And now we we have to do is solve. We can subtract x on the left side of the equation and subtract 26 on the right side. We can simplify and come to a solution that x has a value of 6. Now, we are not finished. Here, in the order to find the angle measure, we have to substitute 6 back into each expression. Doing that gets us an angle measure of 38 degrees for all of the acute angle, the OHS, and subtracting that from 180 give us 142, which is the measure of all the obtuse angles, and now we have completed the entire diagram. So you may choose to use the EXO method or similar color coordinating method to better help you visualize the relationship between the angles that are formed when we have parallel cut by the transversal. And thank you. Bye.